In Part A, evaluate each of the following expressions using a double angle identity. We'll begin by finding the exact value of sine 60 degrees using a double angle identity. Express 60 degrees as a double angle. In other words, factor out a 2 from 60 degrees to get 2 times 30 degrees. We call it a double angle because we have 30 degrees 2 times. Bring up the double angle identities. Use a double angle sine identity. Plug 30 degrees into the right side of the equation. Find the exact value of each trigonometric ratio. We no longer need the double angle form, so return the angle on the left side to 60 degrees. Simplify to get root 3 over 2. This answer matches the exact value of sine of 60 degrees on the unit circle. Note that we wouldn't ordinarily calculate sine of 60 degrees using a double angle identity, since it can easily be found on the unit circle. We are using the double angle identities in this question just for practice. Later, you'll use them with nonfamiliar angles. In question 2, evaluate cos pi over 2. Write pi over 2 as a double angle. In other words, factor out 2 to get 2 times pi over 4. We can use any of the 3 cosine double angle identities. In this example, we'll use the first one. Plug pi over 4 into the right side of the equation. Find the exact value of each trigonometric ratio. We no longer need the double angle form, so return the angle on the left side to pi over 2. Square each term. The answer is cos pi over 2 equals 0. In question 3, evaluate tan of 90 degrees. Write 90 degrees as a double angle. In other words, factor out 2 to get 2 times 45 degrees. Use the double angle tan identity. Plug in 45 degrees to the left side of the equation. The exact value of tan 45 degrees is 1. This gives us 2 over 0. The answer is tan of 90 degrees equals undefined. Now we'll move on to part B. Express each of the following expressions using a double angle identity. We'll begin by expanding sine of 8x. Rewrite 8x as 2 times 4x. Bring up the double angle identities. Use the double angle sine identity. Plug 4x into the right side of the identity. This gives us sine 8x equals 2 sine 4x cos 4x. In question 2, expand cos 4x. We write 4x as 2 times 2x. We'll use the first double angle cosine identity. Plug 2x into the right side of the identity. This gives us cos 4x equals cos squared 2x minus sine squared 2x. In question 3, expand sin x. At first it seems like nothing can be done since we can't factor a 2 out of x, or can we? We write x as 1/2 x plus 1/2 x. This becomes 2 times 1/2 x. Replace x with 2 times 1/2 x. Plug 1/2 x into the right side of the equation. This gives us sin x equals 2 times sine 1/2 x times cos 1/2 x. In question 4, expand cos 1/2 x. One half is equivalent to 2 quarters. The result is 2 times 1/4 x. Replace 1/2 x with 2 times 1/4 x. We can use any of the double angle cosine identities. In this example, we'll arbitrarily use the third option. Plug 1/4 x into the right side of the equation. This gives us cos 1/2 x equals 1 minus 2 sine squared 1/4 x. Now we'll move on to part C. Write each of the following expressions as a single trigonometric ratio using a double angle identity. We write the identity. Bring up the double angle identities. We'll use the first double angle cosine identity. Plug 30 degrees into the left side of the equation. This gives us cos of 60 degrees equals cos squared 30 degrees minus sine squared 30 degrees. We can express cos squared 30 degrees minus sine squared 30 degrees as the single trigonometric ratio cos of 60 degrees. In question 2, express sine pi over 8 cos pi over 8 as a single trigonometric ratio. We write the identity. We need to adjust the double angle sine identity so it matches the question. Divide both sides by 2 to get 1/2 sine 2x equals sine x cos x. Plug pi over 8 into the left side of the equation. This gives us 1/2 sine pi over 4 equals sine pi over 8 cos pi over 8. Sine pi over 8 cos pi over 8 can be expressed as the single trigonometric ratio 1/2 sine pi over 4. In question 3, express 1 minus sine squared 1/2 x as a single trigonometric ratio. We'll use a third double angle cosine identity. Plug 1/2 x into the left side of the equation. This gives us cos x equals 1 minus sine squared 1/2 x. One minus sine squared 1/2 x can be expressed as a single trigonometric ratio cos x. In question 4, express 2 tan x over 8 over 1 minus tan squared x over 8 as a single trigonometric ratio. Plug x over 8 into the left side of the equation. This gives us tan x over 4 equals 2 tan x over 8 over 1 minus tan squared x over 8. We can express the original expression as a single trigonometric ratio tan x over 4.